morning, students of class 12. I once again welcome you in the online classes. Now we are discussing on the group 17 elements. Was only one period on this chapter, that is group 17 element. Now today I will discuss on the sum of the next portion of the group 17 elements. Now in the previous classes we have discussed on the physical properties of the group 17 elements. Now in today's class we will discuss on the chemical properties of group 16 elements. So the discussion is on chemical properties. Under the chemical properties, first is the types of bond or the compounds form types of bond. Now here in the halogen forms the compound in both the bond formation, that is the ionic bond and covalent bond. Ionic and covalent. Ionic bond is formed by the absorption or taking up of electron from any another species, and covalent bond is by sharing of electron. The examples of ionic bond, that is NaCl, KCl, etc. and covalent bond, that is CCl4, etc. Now in covalent bond you can see that it is the non-metal. So generally the non-metals reacts with the halides to form the covalent bond, and the metallic form, that is CaCl2, that is the group 1 and group 2 forms the ionic bond, and that is the p block elements generally form the covalent bonds. So it is the general types of bond of group 17 elements. Next one is the oxidation step. So oxidation step is generally assumed as its valency. Now fluorine becomes being the most electronegative element, it can show the -1 oxidation step. Fluorine becoming most electronegative element can show -1 electronegative -1 valency with the compounds like NaF, etc. That is ionic type of compound. Now the oxidation state is possible for these elements are vary for higher numbers, that is it can vary to +1, +3, +5, +7, etc. That is -1, +1, +3, +5. These are the general oxidation state. Now in fluorine it is only the exception that it can form only the compounds with -1 oxidation state. Now chlorine, as it have the d orbital, so it can valence, it can increase its oxidation state. Suppose if we draw the 3s and 3p, 3s and 3p of chlorine ground state, and 3d is vacant. 3d, this is the ground state. Now when one electron from p orbit is jumped to the d orbit, then here the oxidation state observed for chlorine is equal to +1 oxidation state. In the same way chlorine excited, chlorine excited. In the same way when another one electrons jumps, it forms. So here +3 oxidation state, here +5 oxidation state, and if another one, that is the s electron, is also converted, transported to the d orbital, then it will forms the +7 oxidation state. So here +7 oxidation state. So these are the oxidation state observed by chlorine, and we can see it how this increase in the oxidation state is occurred by using the electronic upliftment from the ground state to the excited state. So it is the general oxidation state of group 17 elements. Next one we have to discuss on the oxidizing nature. Oxidizing nature. Now, from the oxidation reduction concept, we know that from the reactivity series also, the fluorine is situated as the top of the activity series because of its reduction potential. Now, as the value of the positive reduction potential or reduction potential value is positive, so it is a strong oxidant. So, all the halides are strong oxidant. The fluorine having the value of F2 F minus is equal to 2.87 volt, and if we follow the value of the reduction potential, then there is a decreasing trend, that is Br2 Br minus has the value of 1.08 volt. In the same way, if we follow the value of I2 Cl2 Cl minus, Cl2 to Cl minus, it will goes with 1.36 volt. So this is the decreasing trend. So the oxidizing nature is maximum for fluorine, then chlorine, then bromine, and then iodine. It is the trend of oxidizing nature. So fluorine is most oxidizing, chlorine, bromine, and then iodine. Next one, so reducing character of, question is, what is the arrangement of reducing character of I minus, Cl minus, and Br minus? Reducing character of I minus, Cl minus, and Br minus, but not F minus, because F minus does not form because of higher electronegativity. It generally forms +1 oxidation state, -1 oxidation state. Now, for the reducing property, the I minus having the least, that means the electrons are so dispersed around the nucleus that it can release the electrons easily, and so it is highly reducing in nature. So I minus is highly reducing, then Br minus, and then Cl minus. So we can see that when the anionic form, the reducing character is just the reverse or in the molecular form. In a molecular form, we have found that it is the reverse order, that is Cl2 greater than Br2 greater than I2. But in the anionic form, the I minus is the most reducing. Why fluorine does not show, that is why F minus does not show reducing character? The answer will be the basic principle of fluorine, that is number 1, that is very small size, and second one, that is high electronegativity. These are the two factors for which the F minus does not show reducing character. Next one, reaction with hydrogen. Now all the elements, that is fluorine, chlorine, bromine, iodine, generally reacts with hydrogens. It is also under the chemical property, reaction with hydrogen. We know that is HF, HCl, HBr, HI. These are all the compounds formed with the hydrogen. So first of all, that is affinity of halogens towards the hydrogen decreases down the group. Affinity of halogens towards the hydrogen is decreases down the group, because first of all HF, so the compounds is HF, HCl, HBr, and HI. So HI it is a very less stable. HI is very less stable because of very low bond dissociation energy, and HF is strongly stable. So as it is more stable, so the tendency to form halide, tendency to form compounds with hydrogen is maximum for fluorine. So here also the order, that is F2 greater than Cl2 greater than Br2 greater than I2. So the tendency of the halides with the hydrogen decreases down the group. Next one is, if we follow the reaction condition, that is formation of the hydrogen halide, then we can easily prove it that the tendency is decreases. That is, if we using strong condition, that is using catalyzed condition, we can produce HI, but the reaction of hydrogen and fluorine generally occurs in dark. So there is a contrast. H2 plus F2 in dark forms 2HF, but H2 plus I2 here catalyst and 550 degree centigrade is required to form HI. So here strong reaction conditions are required in case of the iodine, but it is occurs in dark. So it is a proof of that. Next one, the physical state of the hydrogen halide. Generally, except the HF, that is hydrogen fluoride, all are gaseous in nature. Nature of hydrogen halides. HF is liquid, but the rest are gaseous in nature. Why HF is liquid? We know hydrogen bonding, and as there is a large electronegativity difference between the H and F, here also the maximum hydrogen bonding is occur here. So HF. So intermolecular hydrogen bonding is responsible for the property of HF to become as a liquid. Next one, thermal stability of the hydrogen halide. Thermal stability. So as the bond dissociation energy of HI is very low, so the thermally it is unstable. Here also the HF greater than HCl greater than HBr greater than HI. So it is the thermal stability. As the bond dissociation energy is less for HI, so it is less stable, and HF is the most stable. Next, reducing character. From this property, that is according to the thermal stability, as it is less stable, so it can release hydrogen easily. So the reducing character is follow HI greater than HBr greater than HCl greater than HF. So this is the very important trends, that is thermal stability is increases from HF to HI, but the reducing character is increases from HI to HF, decreases from HI to HF. Next property, that is we have to study the further property of halides, hydrogen halides, that is reactivity towards oxygen. Reactivity towards oxygen. Reactivity towards oxygen. Now the fluorine forms OF2, O2F2. This is the compounds formed by fluorine. This is known as oxides of fluorine. This is called oxides of fluorine. Next one, Cl2O, Cl2O3, Cl2O7. This is the oxides of chlorine. Third one, that is Br2O. This is the oxides of bromine. I2O5. This is the oxides of iodine. So these are the examples of oxide. Now Cl2O, there are some industrial applications of these oxides, that is Cl2O, Cl2O7. These are used as a bleaching agent in the paper industry. So this is the important use of it. Next one is the oxoacids. So oxoacids, that means having the general formula HX oxoacids, HXON, where n equal to 1, 2, 3. Not all the halides, that is not all the iodides, chlorides, bromides or fluorides form oxohalide in all of its oxidation state. There are specific examples. That is, first of all, in +1 oxidation state, the examples are HOF. First example, that is HOF, HClO, HBRO. Here is the +1 oxidation state example. O, that is 1, and then X. Next one, in +3 oxidation state, it is the example, that is HClO2, HBr. Only the HClO2 is the example. It is known as Hallus acid. This is known as hypohallus acid. This is known as Hallus acid. In +3 oxidation state, and in +5 oxidation state, it is that HClO3, it is halic acid. So hypohallus acid, Hallus acid and halic acid. There are the 3 types of oxoacids that is formed in the different oxidation state of the halogen atom. Now there are some questions, that is acidic strength of hypohallus acid. So acidic strength of hypohallus acid. Acidic strength of hypohallus acid. Now, as the electronegativity of the halogen atom increases, its acidic strength increases. What is the principle? As the electronegativity of the halogen atom increases, its acidity also increases. So we can predict the same, that is around HClO, HBRO, HIO. So the acid is maximum for HClO and minimum for HIO. That is, the principle is the electronegativity is highest here and it is the lowest here. Next one is the what is the acidic strength of HClO4, HClO3, HClO2 and HClO. We have discussed earlier about this question, that as the oxidation state of the central atom increases, its acidity also increases. So here the maximum oxidation state, that is chlorine, it is 7, it is in +5, it is +3 and it is +1. So here also the acidic strength decreases in the order, that is HClO4 greater than HClO3 greater than HClO2 and HClO. So another one question, that is, if we compare this acid, that is HClO4, HBRO4 and HIO4, then what will be the acidic strength of the corresponding acid? So here also the same reason, as the electronegativity of the central atom increases, here the acidity also increases. So HClO4 acidity of HClO4, HBRO4 greater than HiO4. It is the acidic strength of the corresponding hypohalous acid. So this is all about the acidic strength. Next day we will discuss on the metal halides and metal halides also, and then the interhalogen compounds, and then some compounds, that is the chlorine, the HCl, and some of its properties. So before that, you will carefully read the NCERT and also the class note, that is the e-class, and make the note for yourself and continue your studying. Thank you.